I'm Chrisferb, and I'm going to review an example of a confidence interval with a proportion. Okay, so it says calculate the 90% confidence interval estimate for the population proportion based on, and this is p hat, meaning our proportion that is a sample-based proportion. It's not a population proportion. So our sample-based proportion is 0.4 with n of 100. Now sometimes you see p hat being p bar or p hats, same thing. Okay, so to start off with, the parts that go into a confidence interval are these parts. We go p hat, and then it's plus, minus, and then z, which would be our z value, and then the root of p hat 1 minus p hat, and then n. So this, you'll notice this looks very similar to binomial, where we have a probability and then the inverse of it, which is similar to like the Q. Okay, so we're gonna calculate these three separately, then we're gonna put them back together at the end. Okay, so the p hat we're already given, which is our 0.4, so I'm not going to worry about that right now. And our z, we're calculating it to the 90% confidence interval. So let's take a look at the z value for 90%. I have an alternative z table, which I have, it's a little annotated, and I'll explain this, and I'll make this available for anybody out there on YouTube. Okay, I have this annotated for two different reasons, one for the confidence interval and one for hypothesis testing. Okay, so in this case, and I believe this is considered an alternative table, it's not left or right, meaning it doesn't start at one side and then go all the way up to 1. It only goes from 0 to 0.5, so it can be used on either side. Maybe that's a little bit more tricky, but we don't have to think about which table to use. You always use the same table. Okay, we're looking for the 90% confidence interval. So in this case, I have this all annotated, but it says 90%. I'm going to zoom in. So my table here, I've put, I'm going to do a little focus. Okay. It says 90% confidence interval, 1.65 z. So that's actually the 1.65 is what we're going to use. So in this case, 1.65, and it shows how you get the 1.65, and you get it because of 0.4505 plus 0.4505, and it's this value right here. And then when you go out, it is the 1.65. So something to remember with confidence intervals. With confidence intervals, we're essentially, this may make more sense later, we're using the beta of each side, which means the inside of the probability under the z distribution, or the normal standard distribution, the standard normal distribution, but we're using both. We're using the area that's close to the middle, and when we add that up, we end up getting our 90% that way. 0.45, 0.45, we get 90%. When we do hypothesis testing, we end up looking for the tails, and when we look for the tails, then we go and we're looking for these, the total amount and then the tail part. So when we look for, take for instance, 90%, it's a different figure. Okay, so it is 1.65. Put that away. I'm going to back this out a little bit. Sometime I'll do a video just on that table because it's useful. Okay, so for our z value at the 90%, it is 1.65. Okay. Okay, 1.65. So we have that value right there, which is our z. We already have our p hat. We're going to calculate this right now. Okay. Okay, p hat is 0.40. 1 subtract 0.40. So you can kind of write this out if you wanted to. It's, 0.40 times 0.60. And then our n, just 100. And I'll jump to the chase real quick. If you're doing this by hand, you should calculate these pieces and then go and get the root, in my opinion, unless you're all good with the calculator and do it all at once. But you need to be careful about parentheses when you do that. If you do it wrong, then you can go and you end up having some errors because of order of operations. Okay. So just real quick here, the answer is 0.0489. 0.0489. I'll make that more clear in the next part. Okay. So we have this value, we have this value, and then we have our p hat already. So let's put this together. Sometimes I write the plus first, but we'll write the negative first, which makes sense. So that is 0.40 and subtract 1.65 and then 0.04. I'm sorry, 0.0489. That equals 0 minus 0.0806, and then 0.40 plus 1.65, and then 0.048. Of course, it's the same with each one. The only thing that we're changing is the plus and the minus. And we end up with 0.40 plus 0.0806. And the answer is, on each one, 0.3194. So our smaller side, and our larger side is 0.4806. You don't have to write it that way, but that's what each one of these is. The low side and the high side. Okay. Okay. And then the last thing that we're going to do is we're going to do this in the calculator. So I'm going to pull over my emulator, my emulated calculator, which I have links to the calculator. Whenever I do this in a YouTube video, I'm putting links up to the calculator. And the one that I'm actually putting a link to is the online version. So all you have to do is download the actual the ROM and then upload it to the website, and then you can use the calculator there. Okay. On which is clear. Okay, we're going to use one prop z int. And you go to stat, and then we go over twice to the right, and we go one prop z. So this is z test. It's down a little bit further. One prop z int. It happens to be a on this calculator, all the way down. And so we're going to put in our x, which is our number of success that we find. Now, with proportions, sometimes you would think it would be a point, say 0.4, but in this case, it's the actual what it would be based on the proportion. So our proportion that we're looking for was the 0.40 out of 100. So it ends up being 40. Now, if you have something complicated, you can always do this. 0.4 times 100, and it puts it in for you. Okay, n is 100. And then we need to make sure our confidence interval is correct, which was 90%. So it's the decimal 9. Okay. Calculate, and we end up getting our low and our high. So 0.3194, which is correct, and 0.4805. He says our calculation was 4806. So the calculator is always a little bit more precise. Okay, thank you for watching, and have a good day.